This is Algebra 2A Red class. Red sign on it. This is the beginning of Unit 5, which is essentially a review unit. And so we begin here with the calc problem. This is what's going to be called handout 1. The 4 assessments, rather the 5 assessments that go with this Unit 5 standards to be assessed on. I'll call them handout 1, handout 2, and so on. That's another good thing. At the top of this paper, put H period O period 1, handout 1. If you want to put that whole word handout, you can do that. The two that came in, you can kind of just work on this. All right, so that's that. And then we'll see if we can add in some extra pieces. All right, so here it comes. The original equation we know is y equals a b x. In this particular case, someone, after you answer, don't say anymore. What is the a in this problem? Anyone can throw that answer out. 3.2 is close. It's going to be a 5. So the percent will always be the other guy. So we got our 5. That's this amount here. The A in this question, which is one of the questions I'll ask, because this is the additional part. In these exponential functions, the A is something, I'll ask it, see what we would say so that I don't just say it. What does A represent in the problem? Like, usually it's going to be a real world problem. The A is always something. What can you say it is? What you start with, also called the initial amount or the original number, but it's what you start with. In this case, with the counting, that's going to be important. They are going to ask you that question. So you'll get your equation here, A and your B raised to the X, and then they say, well, in the context of this problem, what is A? You would have to read back, okay, are they talking about money? Are they talking about cows? Are they talking about, let's see, the cow starts off with 5 billion E. coli bacteria. So the original amount of E. coli bacteria is what A is in this problem. Sometimes I'll ask about money. Your money grows is the original amount of the loan. And so that question, not hard, but just know, they know you can do this stuff. Now they want to know, okay, when you draw this picture, do you know like what it represents? Someone say what the B is going to be. .032, and again to get that. So this first part, I'm just saying, we'll probably do this one other time on another one, but I feel pretty confident in you now with this. You change the percent into a decimal by crossing out 1, 2, add that 0, so you want it with the .032. Now the way I've said it is you put a 1 in front of it, but technically the rule is this, you will have heard it the real way once. If this is a problem where something is increasing, it's growing, then technically what you're supposed to do is you're supposed to do 1 plus whatever the percent is. So in this case, it's 1 plus .032. If you had $1 to 32 cents, you still get the $1.32. So for you, I'm just telling you, hey, just go ahead and put the 1 in front. The reason I want to say the real thing to you just one time is this. If this were a decay problem, it was getting smaller and smaller and smaller, you would do 1 minus the percent. Now, fortunately, in this case, we've just been doing increases, but just know if it said there was a 0.5% decay in whatever the thing is, then it'd be 1 minus. In any case, they have that 1 point, and there is our formula, no big deal. You put together the puzzle. The first part is what you started out with, just like what you said. The second part is that 1.032, just like David said. You're good to go. Let's draw the picture, and then I'm going to add the calculator part. Again, a new additional part. So let's try this. In this case, do I have space? Down at the bottom, I almost want to write what A was. And go down to the bottom. I'm out of space, but just because they're going to ask it in this case, what is the... Well, I'll fill it. Under the intercepts. All right, so here we go. Here's a picture. We're drawing an airplane. You know, for the sake of this, I think I'm gonna put in the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm gonna scale mine so that it actually goes through the 5, uh, which is where it's supposed to. There's my A. Again, 0A is the y-intercept. What am I putting in here? 0, comma what? 0, comma 5. This part should be going quickly but slowly for you. In other words, I'm not taking that much time with it on this original problem. We'll probably do one more of these with different numbers. All right, so here the y-intercept is going to be what over here? When we write officially, it has to be over here. Yeah, the same 0, comma 5. But it's going to be in this section where they're going to ask, the y-intercept is this 0, comma 5. What does it represent in the original problem? And Latif, what was that again? You said it earlier. So this 0, comma 5 represents the original amount. I'll put A. No, I can say y-intercept. This is the original amount. Original amount of what? Original amount in this case of E. coli bacteria. The part is new and important. So if you don't have that written down, write that down. So what I'm trying to do is do the old stuff. Oh, I would know the old stuff. And then I'll say, like, whoa, we don't have to answer this. Put in this new stuff. Try and squeeze it in if you can. So far, you should feel pretty good. At the end, the bulk of this thing is going to be that. We're going to add a table in a moment, but you guys are good at tables, so that's going to be good. So again, my plan today, for the final, this is Unit 5 for those who just came in. At the top of this handout, you're going to put your name, class color, and U5 and circle it. We're reviewing the one standard at least from each of the old units. And I decided to start with one that you just finished so that it could be nice and easy. All right, let's see if I can chop this thing in half. End behavior. Now they are going to actually ask you what does the end behavior represent in this one in a real world situation. Like, what do those arrows actually mean? So I know some of you have been answering. Let me go ahead and put these guys here one last time. You guys will be experts at this if it ever comes up in the future. Oops. All right, the green arrows are telling us about the picture. As the red graph moves to the right, goes to positive infinity, could someone who has an answer maybe tell me what the red arrow is doing? All right, anyone can jump back in. Monday morning, they want to coach out. That's cool. All right, so here's the deal. Someone tell me what to put after this Y. Positive infinity. As the red arrow goes to the right on the X, it goes to positive infinity. And then the other side, which actually won't be as important, the blue won't be as important this time. I'll explain to you why in a real world situation. Say it again? So you won't have negative numbers. So you still will put in your real end behavior. Okay? That is, as the X travels this way, the red line is trying to come down. Anybody remember what the name of this line is? Asymptote. Good job, Lorena. The red line can't go below that, so it's stuck. It'll flatten out at 0. And I guess I should say this. The official equation for the x-axis, just if you've never heard it, so perhaps some teacher will ask for it. Anybody know the equation of this line? And most people don't. Well, I'll ask, so I can be impressed. Anybody know the equation of this line? It's not simply the equation of the x-axis. Well, it goes like that's going to be a different line, which you're actually going to need this unit, so that's a good answer. But that actually represents a different line. Anybody want to try one? That's a good answer. It is y equals something. Y equals 0. This line is y equals 0 because this line, you see here, y is 1 here, y is 2 there, y is 3 there, y is -1 here, y is -2 here. At this point right here, this whole line goes right through where y is equal to 0. And most people don't know that one. And that's why when we say it's going to 0, that line there. All right, let's see what you have so far. By the way, just in case you don't know, you are passing your test this very moment. You have your equation, your y equals abx. You can turn that in there. You can draw your picture, go through the y axis, or rather the y-intercept. You know how to label it and write it over here. The new piece is, in the context of this problem, what does the y-intercept represent? It represents the original amount. You always start with that. It represents the original amount. Then you have to read the problem and find out the original amount of what. So if you just put, it represents the original amount, I'm going to have to put a question mark by it. Because I don't know, like original amount of bacteria, of money, of, I think flies, and the next problem we're going to look at. So you need to put of what. Then you do your end behavior, just regular old school, and then the question comes, in the context of this problem, what does the end behavior represent? What does it mean in this problem? This one I'm willing to, let's see if I can help you say it without me just telling it to you first. Normally we don't write it. On this one, the x-axis represents time. Now, I haven't been saying it because up to this point they have been asking it. I just want you to be able to do the picture, but now the picture is no big deal to you. Please write the word time. The x-axis represents time with exponential problems. Over time, something happens. In this case, this side here represents how much of whatever you have. So in this case, now on all the problems, time is going to be the x. But this one will change sometimes. It's money. In this case, what is it that we're measuring? The original amount of E. coli bacteria. Let's see if I can write that. E. coli bacteria. Write you E. coli. I hope you're starting to feel what they're trying to do in Unit 5. If I say, okay, well, in Unit 4, they knew how to just produce regular stuff. They didn't have to think what it meant. Unit 5 is like, okay, now that you put it down, you're going to have to tell me more of what it means. My goal, though, is still make sure they can just write down all the original stuff. That way, the little pieces that are broken are just the new thing. That way, when you have to fix a test, I can say, okay, what do we say the x-axis was? Oh, it's time. And how about this side? Well, it depends on what we're talking about. In this case, E. coli bacteria is what we're talking about. Bacteria. That's hard to read. So look right. All right. So here's the, let me ask this question. This arrow says, as more and more time goes on, something is happening with the E. coli bacteria. Can someone tell me what's happening with the E. coli bacteria as more and more time goes on? It's increasing. It's getting bigger and bigger. And that's it. I don't want it to seem like anything crazy. If the arrow were coming down over time, time is always going to be increasing. The E. coli bacteria would be decreasing. So we're going to put it very simple. What does the end behavior mean? The green stuff is what we're looking at. The blue stuff doesn't. The blue stuff doesn't matter because the minute you hit here, the wall, you can't go back in time. You can't go to negative time right before you're born. So the as time increases, the bacteria increases. As time increases, the flies increase. As time increases, the money increases. As long as that arrow's flying up, as time increases, and this is for the green, and as time increases, in this case, bacteria, E. coli, increases. Write that in, write that in, write that in. A little gift from me to you. with the help of Latisse, of course. So far, what are the two new things? A, what does the Y intercept actually mean? And what does the end behavior mean in the context of this problem? So far, only two new things. Here comes the third new thing, even though I know some of you are still right, so let me pause. When they ask you to graph, they're going to ask if you would graph the first, what would happen in the first 5 years. First 5 years? How do I know what's happened in years? Well, the truth is, this part, again, let's add some new pieces. Next to the X, and I don't know how small you wrote, you can put time, and usually it's years. Sometimes they're trying to squeeze in months, but I'm just going to make it years. Months will be in your next class, or at the next level. Hey, why is this important? Time and years. They're going to say, how much E. coli will there be at the end of 5 years? 5 years? Well, what's true is, if we were to put 1, 2, 3, 4, 5 years on the x-axis, then what would happen is we would just go up, up, up on the chart to find out, well, what would happen at the end of 5 years. Well, there's a way that we're going to do it where you're not going to show it on the graph. You're going to show it on a table. If I had a table, and on the x side I had 0, 1, 2, 3, 4, 5, someone said, hey, how much E. coli are you going to have at the end of 5 years? I just find where is x5, and whatever the y is next to it, boom, that's what it's going to tell me. In order for you to show me that you know that, you're going to put the equation into the calculator. You're going to do blue button table, and then you're actually going to write down the table with the first five x's, 0, 1, 2, 3, 4, 5. Actually, it will turn out to be 6, but you'll see what I mean. So notice how I want you to do right now. Calculators, please. Here's your old friend, y equals. You're putting in your 5 times your 1.032. Hopefully you remember how to write that 1.032 to the x power. And then you're going to do a table. It's the table that I want to come and mark. I'm running out of space. I'm not sure where you're going to put yours. Again, for purposes of being a math person, above your table, usually you'll actually rewrite the equation. This piece here is almost the last, second to the last of all the new pieces. But again, nice and easy. Once you put in your table, the only thing that should mess some of you up right now is, oh shoot, I forgot how to raise this to the x power. Oh shoot, I forgot where to find the x button. Can anyone say where the x button is going to be found? Next to alpha, next to the green button, so if you forgot where the x is. And how do we raise that 1.032 to the power? How do you get that x up there? It's a button you hit. The caret button and the square. Oh, she said something. I was like, wow. You said it's next to what? Next to the tan or below, I think below clear maybe. Over there by the gray arrows. So if anyone forgot, oh shoot, I haven't been using these. Go bad. Nonetheless, 0. What was 0? Someone say, once you said one answer, you can let someone else say one. 0, partner to 0, please. All right, you're out. Partner to 1. 5.16. All right, you are out. Someone else? 2. 5.32, you're out. 3. 5.49, you're out. 4. Someone has an answer real fast? 5.67, you're out. And 5, the important one, is what? 5 point who? 85. That's how much E. coli you have in that 5th year. If they're asked about your loan, hey, what's your loan going to be in 25 years? You know, if you got time, you can zero down there. Now, there's a certain way they could ask you to do it. What would the loan be in 20? How much E. coli would you have in 5 years? You could type it in, and in place of X, put a 5. But if you have a table, why not just put in the y equals? Go to table. The only time the table would make sense is if they said, okay, how much E. coli would you have in the 100th year? Yeah, you can have your table, try and narrow it all the way down to 100, but that could take long. Or you can just put in the equation and then actually put in a 100 there. That would just give it to you. But the table is the method I want you to use. All right, let's see what we have here. They have that. Let's have them build the whole thing. Oh, pause. We'll ask questions. We build the whole thing with the new pieces. After you build the new pieces, then I'm going to have you read. We'll solve a last part and then have you read the problem with the words that they're going to use. So like, whoa, it's all this extra words. All right, so there we go. Step 1 is question. Hey, anybody look at this? I'm going to ask one anything on where to get the table. Will it all be as time increases? Yes, as time increases. What happens to the arrow if it goes up? You just have to name what it is. The y-intercept? Yeah. So what was the original amount? I guess I answered any questions. That wasn't good. All right, here we go. Any question I didn't answer? All right, that's good. All right, so what does he need to do? We need to find, at this last stage, they're going to throw in an extra number to try and throw you off. Just see if when you write your y equals abx, you only need to choose two numbers, the a and the b. They're going to have a third number in there that you're going to have to ignore. So as you read through this problem, try to choose the two numbers that you need, and that third one, don't let him mess with you. So what is it that he wants you to do? For the y, do me a favor, actually write down that full equation, the a and the b, and the x. You see on this one I have a y and a dot. What's for the dot? The dot is like a raised dot. It's supposed to be a times bx. Write in the abx for that equation. This is 47. Once you do that, what is it that Thomas wants you to do? What does teacher want you to do, as they say in elementary school? I want you to do for this fly problem everything you just did for the cow problem. The only thing that's new on 47 is they throw in one extra number that you have to ignore, and I won't tell you which one it is. So go ahead and see if you do that one now with the new wording. So this one will give you a good chance. I'll put my A, my B, and X. On the board I just wrote in the equation, which is what I want you to write before the actual problem. This thing here, last time Unit 5 for building exponential functions. Some people kind of went for it. They threw in that third number, and some people kind of went for that thing. What was the A in this problem? That 100 flies is how many flies you began with. All right, so that part's fine. What was the B in this problem? Yeah, the 22, and this one, they kind of got some of you as well. We're so used to having a 0 on whatever. In this case, you turn the percent into a decimal, so always cross out. Find the decimal point in the problem, which in the number 22 is at the end. 1, 2 only. So you wind up with just, look at me, I want to do it too. You see it messing up? Just like Sue did. You wind up with just the point 22. And that point 22 is where you're going to add, of course, the 1 in front of it. So some people, I saw it was good. You had the 22, and of course it's going to be raised to the x. But the good news about that one, that's question number 1. If you have that extra 0, it's true you have to get rid of it. What does that do? It affects your table. But let's just imagine you had the 0, 22. I'd almost want to grade you. I mean, everything else is going to change, but I almost want to grade you as if your table is going to be fine based on that. All right, so I'll do the picture because I saw some of your pictures. We draw the airplane, There's my A, which is 100. See how mechanical it is? For anyone who thinks math is hard, I mean, I get it. Because we've done this problem so much, all these pieces are going to be this like automatic. I'm not even like thinking about when I go for my y-intercept. Someone say out loud what the y-intercept is going to be. 0.100. Someone different say what it means. They're going to say, what does it mean in this context? Original amount of flies. If you just put original amount, I will have to question mark it and send it back. Oh, original amount. Original amount of flies in this case. As a matter of fact, if you had highlight grab on it, I almost want you to highlight the flies in here. Why do you want to do that? Because in whatever problem you get, I want you to be able to highlight what the thing is they're talking about, because that's what you're going to have to refer to. Let's see, the next thing that we need in here is the end behavior. End behavior. And the reason I asked about that memory thing, for those who have a good memory, then each one of these things now becomes pretty like easy. You know, the end behavior is the same picture. And again, you really only have two versions of an exponential function. Either it's an airplane taking off or it's an airplane landing. Airplane landing is them saying it decreases. The thing isn't growing, but it's getting smaller and smaller. And so in this case, sure, why not? Now I feel like a genius, because if anyone ever asked me to draw an exponential function, ask for end behavior, now I barely even need to put my arrows, but do put them. That way, when I see, just in case you mess up by accident, I'll tell you have it. And again, for those who have super memories, at this point, you're like, all right, we've seen it, we get it, but don't forget, in any space, there are people with super memories and other people like, should do it one more time. You know, whenever I get those half sheets back, some people will always write verbally, what could make class better? If we had more time for more examples. And other people are like, what should I just do it and just take the test? So when I look at it like, yeah, the problem of having a class and behavior, in any given class you have two people who need exactly the opposite. That's why at options, it used to be the case that you can do math out of your packets. That way, if you know this section, boom, zoom through this section, but the next section, oh shoot, I need help. Let me go to the tutor, slow down with this. As opposed in the class, if your teacher says today we're doing standard 1, whether you get it or not, you're getting that test for standard 1 today. You know what I mean? So they kind of messed up what option used to be by putting you in classes. It helps most people, but there are some people who just wish they could go a little faster, or they didn't have to sit for 2 hours. They could just do if they can get through it in an hour. What does the end behavior say? You're gonna have to enter this part. She is correct. Hopefully she's taking all your tests for you. But here's the deal. Please do me a favor. Write time under here. This is going to be the thing that's going to help you. You got to write the word time on the X. If you don't put time on the X, when it says what does the end behavior mean, you're going to be like, I don't know. As time increases, please go ahead and put next to this one, flies. You got to write it down. You got to write it down. This is try number 2. Try number 3, we're not going to do all of it. We're going to make this little chart just so we can get used to writing time on that one. As time increases, flies increase. That's what your end behavior is saying. And it's the green side, because as you go to negative infinity, well, you can't go to negative infinite flies. Didn't even make any sense. When you go to negative infinite flies, you want it with 0 flies. Just doesn't make any sense. So as time increases, flies increase. Really, I should put the number of flies increase, but I don't know what you mean. And then the last piece, of course, your calculator, if you punched in the formula, your table. On the on the assessment, where will you put the table because it's going to be broken around? The table will go near the graph. So let's say something, please, graph the first 5 years. Because the graph, you're just going to do a sketch. The table says if you had to put exact numbers, you would. The reason I don't have you do it is because the numbers like 1.174, 1, 2, 3, 4, 5. All right, here it comes. What is that first number? 100. Someone else? What's that second number, please? What is it? 122. Someone different. The third number goes with the partner for 2. Say it again. 102. Say it again. Is the 148 there? 14.8. No, just 148. Someone give me the 3. And then 4. Same person. I get this. All right. Now again, these numbers to me, if your equation is right, then I believe in the numbers. The only way these numbers are kind of off is if you did 0.022. All right. On this one, again, they put in the 6 to try and get us. My hint to you will be, once you start reading this thing, which is why I want you to read it, because again, when you get to the thing, some of you know how to set it up. The 6 months is just additional information. When you are writing exponential function, you know for sure you need a percent. How much is that thing growing? So don't let that part mess with you. And then, depending on what we're talking about, well, what's the thing that's going to be growing? Oh, it's the money that's going to be growing. Why was that important? Because here they have a lot of words, then they do this thing here with the O and whatnot. Technically, I'm going to write it the way we're going to write it, but just so some of you who will find yourself in another math class, the teacher, your Y and X's, he or she would either mark you wrong or give you a hard time about it. So I'm going to show you technically what they wanted you to have. Don't stress your mind. I just need you to have seen it. So let's do what we're used to doing. I saw you do it. We know that A is 20,000. And then the B, again, be careful with this cross out. 1, 2, and if there's an extra space, you got to fill that in with a 0. And then, of course, we put in that 1, this plus 1. So we have our numbers there. So 1.42 raised to the x power. That's what we've been doing. And that will work out. When you put in your calculator, it will do just what you need to. Officially, in some other class, this just so you will have seen it, don't have to do it. They would want you to put it in function notation. If t is the number of years and O is the amount owed, here's how it would be written. The function O, not that we'd ever use O of t. Well, let me try it this way. And I'll throw in this t in a second so that they can see that. The name of the function is O. In terms of time, which is what the x is, everything else will be exactly the same. But it'll be raised to the t power for time. You don't have to write this second part. This is just so some people have seen the function notation. The function O, it looks like a big 0, which is why we don't use 0. So I'm so surprised. Like, you guys breaking the rules. We don't use O's because we don't know if 0 equals all that or O. So O equals all of that. The question is, I need to realize, a function is a car. Who drives in the car? We put right here in the front seat. T is riding in the car. This thing over here is all that works there. So whenever you think of a function, it has a name, and whatever letter you're going to be using, whatever person will be in the car, in this case it's going to be T, they are riding in the car. That's how you write function. Car, and who's riding in it. If I were writing, if this were a Z, like another person, the car and a Z would be riding in it. So when you see function notation, the outside letter is the name of the function. Oh, it's a car. It's an O. Who's inside of it? The T, whatever letter is going to be used in the function. All right. Last thing I want you to do on this one, please put time. One last time. I'm not saying time again, but you're going to need time on your thing. What's that side thing? What's going to be going up and down? So I'll put a dollar sign. I'm going to put loan. I'm going to put money. It's that important. We're not even graphing it. This is it. After this, I'm going to leave this alone so that when you write the end behavior, as time increases, the loan amount increases. As time increases, the money increases. You have to have the name of that thing, which is why when you read the problem, oh, it's talking about a college loan. Do the last thing. So right now, let's say what I'm about to say next, you don't get. You have 80% of what you're supposed to have. If something's broken, I think for you all, it'll be easily fixed. The last thing that we need to do is the very final question. That will say something like, your loan, the original amount is $20,000. If you don't pay back that loan, every year the interest will increase, and now you have to pay back even more money. The original $20,000 plus the extra interest. The question you might be asked is, how long will it take for this $20,000 to turn into $30,000? Well, you have to pay back $30,000 because you didn't pay any of it back. How much time would that take? Well, we're going to put an equation in, not on this one, but there's another one. And we're going to do some logs, and that'll be it. For some of you to remember, like, oh, I remember that. Some of you are like, I never got that the first time, and I still don't get it. And that's fine. That's okay. It's UNFI. See you next one. All right, here goes. So let's see. What is a page where we're going to answer a question like that? By the way, even though we're not doing all the work here, if this were the problem, you will still do all the equation, the y-intercept, what does it mean, the end behavior, draw the picture, blah, blah, blah. You do the whole thing. Just we're not doing it now because I feel like you have it. What is that page right back? See what I'm saying? Hey, if this were a test question, you'd be saying, oh, my neighbor owes that much money for the brand new car he bought last year. The interest rate, boom, you mark that. Interest, this is like it jumps out, your B just jumps right out at you. But he will not start making payments until he's done with the university work. Let's see, exercise that the amount he owes, ever gets to 35,000. That's when it starts messing with some people. Unfortunately, in this problem, they tell us what the equation is. If you had a highlighter, I want you to highlight this guy here. Somebody like, well, how did they not use the 30,000 and not the 35? But there are two numbers in there, and they're both money. Oh shoot! Let me read this thing. My neighbor Alex owes 30,000. That's the original amount he owes. So above that original amount he owes, my hint is probably going to be if there are two money amounts in a problem, probably that first one is going to be the original amount. Let me see if I can read this because this is the last part. Again, if you didn't get this part, I'm okay with this. This is the last piece of the puzzle. If you have all the other pieces of the puzzle in this one, all right, let it go. What's we can do here in a few minutes. We keep reading. Alex decides that if the amount he owes ever gets to 35,000, it will be too much for him to handle in the monthly payments. If the function for the situation, that is, if they're nice enough to put a P and a T there, if we had to put this in the calculator, your calculator won't accept a P and it won't accept a T. You have to write that as a Y equals X. Okay? How many months or years will it take for the amount owed to reach 35,000? That's the way they ask it. It's all it means. Put a P below that 35,000. Put a P below that 35,000. All they're asking is this. If I were to replace P with the 35,000, what would T be? In other words, how many years would it take for all this jump on this side to equal to 35,000? Now, standard 3 on the last test, the very last problem had something just like this. Some people were able to do it, other people didn't. You didn't need it, but it goes just like this. 30 and 35. In the case of P, you know what, let me write the P thing down so that people can see what they've filled in. P equals, it's 30,000. 1.045 raised to the T power. Then I'm going to write it in. Why is he writing this in? So that if someone has to see the video of the steps, numbers just don't pop up like, whoa, where'd that come from? They see the original, They see the P over there is 35, so it's going to write in the 35,000. Yes, an extra step, but it doesn't take forever. At this point, I'm going to put like 3 to 4 minutes on the clock, and I'm going to see if someone remembers how to solve this problem. My hint is you got to do some of that 30,000 first, and then eventually to get that T down, there's a certain word you have to write when you do division. So I'm going to stay there to see what happens. Step 1, hey, someone say out loud, what's the first thing I'm going to do to try and solve this problem? I am going to divide it. What am I going to divide? So step 1, I'm trying to get to that T. The way you get to the T, you get the people furthest away from it first. What did that 35 divided by the 30 give us? 1 point something. 1.014, yeah? So step 1, we divide here. These guys are gone. In the other class, I had this one student who would divide the 1.45. I think it's in the other class. When someone's done that before, they divide that first, and then they mess around with 30 in it. And that's the thing that you got to get rid of the stuff furthest away from the T first. And then I just leave this with this 1.045 raised to the T. 1.16? Okay, I'll go with the 1.16. Okay. Just wrote that 1.04. Check in your calculators to make sure that you're getting the right thing. So again, 11.6. Now that one, punch it in again because I feel like I know 30 can go into 35 only one time. So it might be a thing. So that one, this one, different. But here's the good news. Let's imagine she did the 11.6, but she wrote this step here. And then after 11.6, she did with the 1.45 what I'm about to do. There's a chance I might go with, okay, right step, punch in the wrong button, whatever. So write your steps down. That way when I look at your stuff, like, okay, they're good. All right, someone tell me what's the next thing I'm going to do, please. Oh, I heard someone say something. Or is that just my imagination? Yes, people at home, they're thinking. They're not going to just get... All right. I'm going to say technically divide, even though it's a lie. It's kind of wrong to say that I'm dividing that. You announce, oh, make sure you divide your 1 point in your other class. Whoever the other math teacher is, if he or she is like about the truth, they were like, no, you do not divide that. What foolish person told you that? And he was like, my old teacher, Mr. Cifuentes. Yeah, that's what I named. All right, yeah, I don't know how to say that you're not dividing it. It's a long process here, but even with my short version, some people aren't even getting that. So why would I do the long version? You see what I'm saying? I'm doing the short version that I just made up. Nonetheless, I don't know. I'll say it this way. You divide as long as you use what word? What word are we using? Yeah. As long as you're using log on this side. That's technically what happened. You wrote the word log here. The T came down in front, and then you did log of this divided by log of that. So you wound up doing all of this stuff. As a matter of fact, I'm going to write some here, and I'll tell you erase it. Technically, you're supposed to write the word log here. That's really what happens. But why would I tell them to do that? Because some people are like, look, too many steps. How many times do I write log? I'll just write every single step. No. All right. And then here we are at the end. So again, people with good memories, you're at the end. This is that last extra piece at the very end. Someone say what log 116 divided by log 145 is? 3.37. The question is kind of like, what did we figure out? Like, what does this answer mean? I'll ask someone they know. I don't even know what this answer means. T equals this 3.37. Jesse got it right. It's the amount of years it would take for this loan of 30,000. You got 30,000. You borrowed 30,000, but you haven't been paying any of it back, so that interest has been accruing. So in about a little over 3 years, now you owe me $35,000 instead of 30,000. Which is why you want to be in the banking industry or in the loan industry. You give people some of the money, and you tell them, hey, yeah, you can borrow this here. It's a credit card. You can borrow that money. That's cool. $5,000 on a credit card. Your interest rate, though, is not going to be this 1.0 thing. I'm going to make your interest rate something like 13%. So this will be like a 13 in there, and that thing will accrue and accrue, and that 5,000 will turn into like 15,000. Then you're going to pay the minimum payment back on bit by bit as they get rich. Take a look at it, see if you want. So for those at home, I went to page 49. 47 is the fraud problem, and I'm asking them how many years will it take to get to 150 flies. The people who got the last problem right, this is super easy for them. For those who didn't get the other one, they get one final chance to divide 100 or divide 122 because they're about to get on an assessment. Mention all the other stuff. That'll be it. Alright, here it comes. Step 1, what am I going to do? Substitute and then divide, right. So you'll think of the same thing. So there's my 150, put that in. Step 2, I'm dividing that 100. What's that 150 divided by 100? 1.5? I wanted to change to something totally different, but so I'll take it that way. This is so mechanical. I don't know what it means when I'm doing, but I just do it. What word do I put in front of the left side to? I got it right. Oops. All right. What does it come out to? 2.03. What does that mean in this case? 2.03 years is how long it will take to go from those 100 flies to 150 if nothing changes. All right, take 2 minutes.